Hi everyone, good morning. I'm Kito Chen from RISC Technology. Greentai and me will talk about the updated state of the RISC-V software. And RISC Technology is one of the main contributors to the RISC-V software ecosystem. We will contribute several software projects for RISC-V, such as toolchain or Linux kernel. And the RISC-V software open system ecosystem continues to advance over past year. And there are many projects upstreamed in past year. However, upstream is not mean complete. It's still a lot of work to do. So today I will talk what's new in the past year. And I am one of the RISC-V toolchain developers. So I will start from the toolchain part. And the first one is the GNU toolchain. I think it's the basis of the whole open source project, the basis. And it has been upstreamed 2 years ago, and so it's pretty stable now. So there is only new features are introduced last year. First one is RISC-32E. RISC-32E, I know it's in the spec for a long time, but now you can build your own RISC-32E product with the upstream toolchain now. And the second one is the interrupt attribute. It allows you can write your interrupt handler in your C program. Let's make your life easier. And the last one I think is the most important feature this year is ELF attribute support. It can be record more information into your object file, include the architectural info, stack alignment, or version of privilege spec. It could be used for your disassembler, linker, or loader to detect the incompatible issue. In fact, it's a kind of tool to face the extension fragmentation problem, because the first step to face the problem is the know the problem. And you could find more detail from the RISC-V mailing list for more discussion. And of course, you can find the spec from the RISC-V ELF platform specific API document. And the next is the debugger. Yeah, the debugger is very important thing in your development cycle. And especially thanks to Mikasa and the Sci-Fi guy continue to contribute on that to make the debugger more stable now. And the GDB support for software single step last year, and Linux FreeBSD platform support. That means you can use your GDB natively on the RISC-V, Linux, or FreeBSD. And OpenOCD was in bad shape last year, but today it's upstreamed and it's getting more stable now. And next one is GLC. GLC is upstreamed in last year, but it's only included for RE64 support. Special thanks to Sci-Fi and Bruce Specker and the Red Hat guy to contribute that. And now the RE32 supporting is coming. It's almost ready to upstream, but not upstream it. It's because waiting for the Linux kernel is to changing the time-related API to resolve the RISC-32 2038 problem. However, we could expect it to be upstream this year. If you want to get a try, you could find the latest stable branch from the RISC-V GLC GitHub. And I believe it's most stable branch you could find. And the last one is the LVN. LVN is another compiler, but it's more like an infrastructure. More other software are dependent on it, such as Rust, Haskell, or the TVN. And RISC-V LVN project is contributed by Low Risk, RISC Technology, and many other contributors. And last year, there is only support for RISC-32 INFT code gen. And today, it's almost kind of the same state of the GCC, the RISC-32 and RISC-64 INFT code gen is supported. The only missing part is the hard float point coin convention. But I think we can expect it will compare this year. The low risk guy is working on that now. And the next one is the LLD. It's another linker implementation in the LVM family. And it's first in a smaller implementation than GNU's linker. And we will contribute our own RISC-V port to the LVM foundation. So RISC-V support will be included in the latest stable release for the LLD. And I think it will be released this month. So you could find that from the LVM official site soon. And that's all my parts. GreenTie will continue to talk about the update status for the Linux kernel and the RTOS. Let's welcome GreenTie.
Hi everyone, I'm GreenTie. I'm going to talk about some system software status. And I'm going to talk about the Linux and U-boot FreeRTOS and Arduino. And for Linux, we'll talk about how we verify our Linux kernel and what kind of tool we provide to debug our Linux kernel and how do we evaluate the Linux kernel by the perf. And some important patch set we send, yes. So the first part is how we do the Linux kernel verification. We run the Linux test 3 project. As you know, this project is mainly used for verification for the user space. And at the first time when we run this test 3, there are more than 200 failures. And as you can see, these failures has reduced to 95 failures. And most of the failure is because of the kernel config disable or the timing issue. And yes, this caused many times to fix it. So if you guys are interested, we hope that more people could contribute your effort to find out the root cause of this Linux test 3 project. And for the kernel space, we enable many kernel config for the debugging and the torture testing. And as you can see, there is a post in the main list. The kernel would hand in a log torture test when config preempt is enabled. So we found these issues too, and we fixed this problem, and we send the patch back to the mainline, and it has been merged to the mainline. So there are still some failures in the kernel space and in the user space. So hope you guys can contribute your effort to the Linux community. And speak of the tool, yeah, we know debugging the Linux kernel is not easy. So we provide some tools to debug the kernel. The first one is ftrace. And this is an advanced version, so it supports dynamic ftrace, so that it would not reduce the performance too much. So that you could use this tool to know your calling sequence. Then you could know maybe where the bug is, and you could use this tool to debug the kernel. And this feature has been merged to the mainline too. And the second part is perf. And this tool is used to evaluate the bottleneck of the system. It could provide some information for you to profile the whole system. And this feature has been merged to mainline too. And Alan will talk more about it in 10 a.m. this morning in the next session. And this feature is merged to mainline, yes. And the next part is about power management. We implement the suspend to run feature. As you can see, this is our Andes RV64 course, and it's a SMP course. And you could use the general suspend to run command from sysfs to sleep the whole process, and your system will go to sleep. Then you could wake it up by the UR interrupt. So this feature has been verified in our platform, and we may send this page in the next few months. And the second one is the power break feature. This feature is allow user to reduce the power consumption. And we also know that Western Digital also sends some important patch sets about CPU hot plug. Yes, but I didn't mention too much about it. Okay, so the next part is the these two features are also important features I thought. The first one is the kernel module support. As you know, the first version 4.14, it doesn't support the Linux kernel module. And we know this feature is very important to all the kernel drivers. So we port this feature for RV32 and RV64 to support all of the location type. And this feature has been merged to mainline too. So now the RISC-V kernel could use the kernel module now. And the second one is a patch set for non-coherent agent RISC-V cores. We know there are some customers who care die size very much. So we provide a patch set. This is a general framework for RISC-V cores without coherent agent, so that you could use the correct catch flash operation in this framework. And this has been verified in our AE350 platform. And this patch has sent last year, but it is not merged to the mainline. But if you want to use it, you can still get it from the main list. And I'd like to talk about our AE350 platform. And we run Fedora on it. This is our AE350 platform. There is a storage for SD card and Ethernet MAC in it. It is able to run Fedora distribution. We just download a Fedora distribution on the internet and use the dd command to copy this file to SD card. And we don't recompile anything or modify anything of this package. And we just change the device tree script to make sure the booting is from SD card. So as you can see in our V5 S25 platform, and the Fedora image could run on it. And we can even install package in it. Through the Fedora DNF command, we install a HTOP RPM in it, and it is able to use too. And Fuwei will talk more about it at 10:15. So the next part is about the U-boot status. The first one is SMP support, and this part is still under reviewing. And we believe it might be get merged in the next few weeks, I think. And the SMO is supported now. In our AE350, more drivers are supported for ANC, Ethernet MAC, SMC, and SPI flash. The Sci-Fi FU540 board is also supported. And thanks to all the contributors from Sci-Fi and Western Digital. And the next part is FreeRTOS. Our FreeRTOS development passed all FreeRTOS test suites, and it supports our AE250 and AE350 platform. We also support the low power mode. It is based on FreeRTOS tick list idle mode, and based on the RISC-V standard and time compare feature. We reduce the power consumption by stopping periodic timer interrupt in idle mode. So you could just set the timer event to the nearest event, so that during the idle task you will not receive any timer interrupt, so that you can reduce the power consumption. And we also provide a useful tool for user to debug the FreeRTOS. In our IDE, you could see task information and event information when you are debugging your FreeRTOS. And this is called awareness debugging. We use a Python script to pass in the FreeRTOS kernel data structure and print useful information in our IDE. We have an Arduino compatible board called Corvette F1. And as you can see, this Corvette F1, there is a shield in it. It's an e-paper shield. And you can use the standard Arduino IDE through the board manager to install our packages, so that you could find Corvette F1 in the supporting board list. And then you could run all the Arduino compatible project to build and run in our Corvette F1. So last part I'd like to talk about is future work. And we know the verification is very important, so we will do more verification on the LTP and the Linux kernel self-test. And about the new feature, we will list some new feature, and hope if you guys are interested, you could choose some to do, yes. And thanks to all the contributors to the RISC-V software community. Thanks.
Hello, I want to ask about the cache problem, because I think current RISC-V specification didn't mention about the line size cache validation. And the main cache validation is dense I, right? It especially seems very whole size cleanup. So is that any suggestion, or do you need anything difficult to porting the cache operating function to Linux?
Yes, as I know, we may want to host a cache test group to discuss about it, and it may talk about the cache line size, as you say. So the instructions should have to flash a cache line, and no matter what the cache line size is. And I believe the cache test group will talk more about it. Yes.
Any other question? So there is a cache test group. So you are cooperating with it?
Yeah, we hope we would host a cache test group to discuss these issues.
Thank you for your contributions on the Fedora Linux. So I know that's an FPGA board that you're currently running. Do you have any plans to, even though it's slow, to add graphics or somewhere where you can have a GUI?
Graphic. Should Charlie answer this question? Oh, Charlie want to answer this question.
Yeah, as we go to a higher, more complicated system, higher performance molecule, we definitely have the interest, and actually we're working with partner to have a test chip as a demo vehicle, and also to encourage more people to develop software on top of it, and we can see we're